Hello, everyone. My name is Julie Bolduc-Duval, and I am the director of a program in Canada called Discover the Universe. Our goal is to help educators mostly across Canada, but it's online and free, so feel free to go check out our website. I'll give it to you in a few minutes. It's to help educators teach astronomy, mostly teachers, but also informal educators. And for this project, the ClimateApp and its educational resources, I collaborated with the Professor Nicholas Cohen from McGill University in Montreal. So just to tell you a little bit about the ClimateApp, I will show it to you in a minute. I'll show you how to use it. It was developed by Nick's team at McGill, and he contacted me a few years ago saying, he had educational activities mostly for university level students, and he said it could be adapted to high school students. I thought it was a fantastic idea, so we've been collaborating for the last few years, and I want to mention that I don't think the project is over because I think there's a lot of potential still, and we are looking at developing new resources with the ClimateApp in the next few years. So the ClimateApp, here's the URL, climateapp.ca, pretty easy. And the activities, including the Google Slides, are found on the Discover the Universe website, which is the program I run. And I want to mention that everything is also available in French because Discover the Universe is a bilingual website, is a bilingual program in Canada, both English and French. But for now, let's go have a look at the ClimateApp itself. You can use it directly in your browser. Here you have the toggle to go from English to French, and it simulates what happens with how much light you receive from the star or the sun, depending if you're on the Earth or another planet, and the surface temperature. So this is a bit what we want to work with. What's the surface temperature depending on different conditions? You have the advanced level. I personally don't use that as much. I stay with beginner. And for now, for the first part, I will remove the atmosphere to make it even simpler. So what we have here is the surface of the planet. And as I mentioned, we can either use it for Earth and understand what happens on Earth, especially the greenhouse effect. But I love that we can also simulate the temperature of the surface of other planets. So it can be used for exoplanets as well and try to see, for example, if they would be in the habitable zone or not. I love the fact that we can do both with the ClimateApp. I think it's a very strong point for this app. So here we have the star or the sun and the light that the planet receives. Part of it is reflected, part of it is also absorbed, and what is absorbed is actually remitted as part of it is remitted as infrared light. And you can see here the surface at the temperature at the surface, minus 18 degrees right now. And the greenhouse effect is 0 degrees. It just means that this is the same. You'll see later when we add the atmosphere, the temperature of the surface of what the temperature would be like without the greenhouse effect will be different. And then we'll be able to say that the greenhouse effect increased the temperature by 20 degrees, for example. So now we can play with the sliders. This is how much energy it receives from the star. So one is what the Earth receives from the sun. We could go 10 times more energy. You can see the temperature went up big time, or 100 times more energy, much higher again. Or you could go with less energy. And of course, it's much colder. Now, if we leave it at 1 for now, and we play with the planetary reflectivity, or the albedo, if you prefer, we put it as planetary reflectivity and as percents because we felt it was easier for high school students to understand those concepts in percentage. So it's a fraction of starlight that's reflected by the planet. So again, Earth is 30%, or you could have 0% that is reflected, or you could have 100%, and you can see the change in the temperature as well. If I come back to 30%, this is actually a simulation of what the Earth would be like without an atmosphere. So without an atmosphere, the surface of the Earth would be minus 18 degrees Celsius. So there is some greenhouse effect happening in the atmosphere, and it's a good thing at first because it warms up the planet enough for us to live. Of course, now with the burning of fossil fuels, the greenhouse effect is stronger, and that causes a problem. But now let's add an atmosphere. And here, well, you can see the blue layer that was added. That's the atmosphere. And we also have new arrows. So the infrared emitted from the Earth now can go into space. Like part of it will go into space, will leave the Earth, but part of it will be stopped in the atmosphere, then the atmosphere will absorb it and re-emit it in all directions. So the infrared will be re-emitted. Part of it will leave the Earth, part of it will go down towards the surface. Technically, it goes in all directions, but we're just leaving sort of the net effects. Either it leaves the planet or it comes down to the surface and warms up the planet. So we sometimes say that the atmosphere traps the heat. That's a bit of simplification in the sense that the atmosphere absorbs infrared and it re-emits infrared light up and down. But again, you can play with the infrared opacity. It blocks more light, so the greenhouse effect will be stronger. You can see here the temperature of the surface would be 24 degrees, while it would be minus 18 without the greenhouse effect. So the greenhouse effect increases the temperature by 42 degrees. Or you can have a lower opacity, and then the temperature change is not as strong. So again, simply playing with the slider really helps you understand what's happening. So 3 sliders, pretty simple, a lot of potential. So let's go to the activities, and I will take you to the Discover the Universe website. I feel bad showing this to you right now because we are in the process of launching a new website in the next few days. So probably in the meantime, between when I record this and when the Shaw workshop happens, actually this page will change. However, it will be similar. You will have different resources, so just make sure you find the one for the ClimateApp. I just want to mention that you can also change to French if you are interested. We have everything in French as well. Appli Climat right here, the different resources. But let's go back in English for now. So you have the link to the ClimateApp. I created a series of slides. So this is the Google Slides presentation. It says Google Slides. Hopefully you can access it. If not, email me. I could send you a PowerPoint version if you prefer, but we like having it online. And I won't go through everything. I just want to mention, like, there's a short video with Nick explaining why he created the ClimateApp. And this isn't meant to be a series of slides that you show in its entirety to your students. It's meant to cover all the concepts you need to understand before you can fully use the ClimateApp. But depending on the level of your students, some of it might be obvious, or you might not feel the need to show the slides. But we have 5 sections, so how sunlight affects the Earth. And we also always have key points, and then explain a little bit what happens, that some light is reflected, some light is absorbed, depending on, we talk about the albedo a little bit here. We don't necessarily mention albedo, but how snow and ice will reflect a large fraction of the light, but water and dark materials will be different, will mostly absorb it. Then we talk about the electromagnetic spectrum, mostly to bring up the concept of infrared light, and atmospheres in general and on Earth, and what happens in the atmosphere. Again, here the global effect towards and away from the surface. And in the end, we also talk about exoplanets, because there's an activity about exoplanets. And so we talk a bit about the TRAPPIST-1 system more specifically. Now, if I come back to the list of resources, there are 2 activities right now, Introduction to the ClimateApp and the Greenhouse Effect. And what I suggest you do, there's some basic explanation here. You have the answer key as well. But the best way to learn it is actually to go through the student worksheet yourself. And basically, it just does, this activity is mostly to play with the sliders, understand what it does, and understand at the end how we create the greenhouse effect on Earth, and what the temperature would be like on Earth without the atmosphere, with the atmosphere now, and what will happen as we burn more fossil fuels, that the infrared opacity increases. So that's the first activity. I explained it very quickly because this is similar to what I did in the demo. And then the second one is about the planetary system TRAPPIST-1. Again, some background information here, instructions, answer key, and then you have the student worksheet. And I really like this activity. What we do basically is that we go to a website, the link is given, to find the irradiation. So basically how much energy the planets receive from the star. This is something we can calculate because we have the type of star, we know how much energy it emits, and we have the distance to the star. And then we make some assumptions, but we try to estimate the surface temperature using the ClimateApp. And then the students are asked, like, we also bring the idea of, is it in the habitable zone? Yes or no. But we also ask them afterwards to think about the assumptions they had to make. At first we go without an atmosphere, Then we add the atmosphere, we change a bit. What if the planetary reflectivity is different? So anyway, a lot of potential, a lot of great activities. So I highly recommend you check the ClimateApp in our resources on Discover the Universe. And if you have any questions, I won't be available to answer them live because I'm at actually another teacher meeting, but Nick will be there to answer your questions. Thanks a lot, everyone.